Hello, geometry class. This lesson is on properties of parallelograms, section 6.2. And what you should have out right now is your notebooks. You should be ready to take notes on everything that's in this presentation. And keep in mind that you can pause or ask your teacher to pause if he's playing this for you. Um, and rewind and talk about whatever's been presented to make sure you have a full understanding. So today we're going to talk about parallelograms. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. So that's the definition of a parallelogram. So if you're given something's a parallelogram, the definition says it's a quadrilateral, so a four-sided polygon with both pairs of opposite sides parallel. I'm going to go over some properties of parallelograms now. Make sure that you get all this written down. The first property I'll talk about is if a quadrilateral is a parallelogram, then opposite sides are congruent. So that's something you know. If you're given something is a parallelogram, opposite sides are congruent. Also, if you're given something is a parallelogram, opposite angles are congruent. And I've got a diagram for each one of those showing. So make sure all these are in your notes. If they're not, then write them down. Consecutive angles are supplementary. That means angles that are right next to each other are supplementary. Or angles that share a side are supplementary, which means they add up to 180 degrees. So those share a side, those are going to be supplementary. These two are supplementary. These two are supplementary with each other, so Q and R. And of course, the last set there, R and S. They're supplementary. The diagonals are going to bisect each other. So the diagonals go from opposite vertices. They bisect each other, which means these two segments, PM and MR, will be congruent, and QM and MS will be congruent. Each diagonal separates the parallelogram into two congruent triangles. So if you just draw one diagonal in, you'll have two congruent triangles formed. And it's quite easy to see this. One way would be, opposite sides are congruent. And then you have reflexive property for side, 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 or, opposite angles are congruent, side, angle, side. There's a lot of different ways you could prove that. And then if a parallelogram has one right angle, then it has four right angles. So if you know a parallelogram has one right angle, then all four must be right angles. You know this because opposite angles are congruent, and adjacent or consecutive angles are supplementary. So if that's 90, that has to be 90. If this is 90, this has to be 90. So make sure you have all those written down. So then you can pause here and ask yourself, are each of the following parallelograms? So why don't you pause and answer those together. So you should have answered yes on the first one. This is a parallelogram because opposite sides are parallel. That's the definition of a parallelogram. On number 2, you should have said no, or there's not enough information to say that, or we don't know. You know one set of opposite sides are parallel, and you know one set of opposite sides are congruent, but that's not enough to say that you have a parallelogram. And then what's the problem on number 3? Well, it's not a quadrilateral. You've got 1, 2, 3, 4, 5, 6 sides. A parallelogram is a quadrilateral with opposite sides parallel. So this is also no. So what I want you to do right now is find a partner, probably the person right next to you, and answer the questions on this slide. STUV is a parallelogram. That's what's given. Find the lengths of TU, WT, and VT. Pause the slide now and take the time to do that. So without too much effort, you should have known, well, if SV is 12, the opposite sides are congruent, so TU is 12. And WT, you know that the diagonals bisect each other, so if VW is 14, then WT is 14. And for VT, well, that's just 14 and 14, which is 28. So what I'd like you to do now is find a new partner. So take the time, go find a new partner, and then find RST XZ and the measure of angle WZY in the parallelogram given. Should pause now and do that. So you should have found that for R, you know that this 4R should be equal to 18 because opposite sides are congruent. So set that up. Solve for R, should get 4.5. For S, you know diagonals bisect each other. So 8S should be equal to 7S plus 3. Solve for S, and you should get S equals 3. For T, let's see, where's T? So T, this one's a little bit trickier. Let me get some of this out of the way. For T, you're looking at this angle formed here. Well, remember, you've got WX is parallel to ZY, and here's a transversal coming through, so this angle and this angle will be congruent. So 2T equals 18, so T equals 9. Then you've got XZ, that's this whole diagonal. You already solved for S. 8 times 3 is 24. Remember, these are congruent, so 24 plus 24 is 48. And then find the measure of angle WZY. Well, that's this entire angle here. And you know that this angle plus this angle needs to equal 180. So 180 minus 18 degrees minus 40 degrees will give you WZY. Here's the next set. Find a new partner and then solve for EH, XY, and the measure of the two angles shown here. Again, EFGD is a parallelogram. So when working through this problem, EH, we know the diagonals bisect each other, so since HG is 8, EH is 8. There's no work involved. For X, this entire angle is 7x plus 4. This one is 50, so I know them added together needs to be 180. Set that up, solve for X. X is 18. For Y, opposite sides are congruent. So 6y minus 9 needs to equal 21. Set that up, solve for Y, you get 5. EDG, so this angle here, needs to be is congruent to its opposite angle, so it's 50. No work involved. And then FED, we know consecutive angles are supplementary, so they need to add up to 180. 180 minus 50 is 130. Last thing I want you to do is get a new partner, take a look at the proof given, and write a 2-column proof for what's shown. What you need to, one thing you need to know is we actually have this little symbol right here. That is the symbol for parallelogram. So when you have that drawn, that means parallelogram, M-A-T-H, which means, remember, the definition of parallelogram means opposite sides are parallel. That's basically what you're told. You know a lot of other things if it's a parallelogram, as you've learned earlier this section. Then MN is congruent to AT is given. Go ahead, go through this proof, pause this, write it down, see what you can come up with. You should only need to use the number of blanks given. So here's the proof that I wrote down. I wrote the two givens down first, of course. And then from there, I know that MH is congruent to AT, since opposite sides of a parallelogram are congruent. And I already knew that MN was congruent to AT, so since both MN and MH are congruent to AT, MN and MH are congruent to each other. So since those two are congruent, the base angles theorem tells me if two sides of a triangle are congruent, then so are those base angles, because that's an isosceles triangle. Then my proof is done. That's it. Take the rest of the time to work on your assignment. It's shown on the board here. This is page 407 through 409, numbers 9 through 24, 31 through 36. Try to get done as much as you can in class, and we'll take questions on that when you come back from break. I hope you enjoy the break, and take some time with family.